Hello, I'm Steve Parola from New England Ropes. On today's video, we'll be talking about mechanical advantage, particularly mechanical advantage using pulleys or blocks. Pulleys or blocks come in many styles. We have a high-strength marine type pulley here. We also can utilize safety and rescue style pulleys. This particular one is an easy open pulley, so it's what we'll be using in our test today. Pulleys can have a single sheave, you can have a double sheave, even 3 and 4 sheaves in your pulley. As part of our test, we'll be using a digital scale to see how much force is applied to lift a weight. We'll be using a 20-pound weight and, of course, some low-stretch polyester rope. So we'll start by weighing one of our weights. We have 2 identical weights. And as we put it on our scale, we can see we have approximately a 20-pound weight. To demonstrate the concept of mechanical advantage, we've set up a test with 2 configurations. The first configuration is a simple redirectional pulley system, where the second configuration will be a mechanical advantage. In a redirectional system, you have a fixed pulley with the line coming from your load through the pulley, and then you can apply your force. And it's simply redirecting how you're applying the force, be it from this angle or straight down. If we attach our scale to it, we will see that we've redirected the force, and we can now pull down to lift the weight up. For every foot you want to lift that weight, you pull 1 foot. And as you can see from the scale, it is the same load. We've just redirected the force. So now let's look at mechanical advantage. Here in our mechanical advantage system, we have our pulley attached to our load. And it is a moving pulley because it's moving up with the load. The rope is attached to a fixed point, so we have a force being supported through this line, and the force that we're applying on the other line. So it's a 2-to-1 mechanical advantage. So we should see half the force necessary to lift it than we did in the other system. So we'll attach our scale and lift. And as you can see, half as much force is applied to lift the same weight. One thing you'll notice in a 2-to-1 system, for every foot you want to lift your weight, you have to raise 2 feet. It's a 2-to-1 system, both in the amount of rope needed and in the force applied. In simple mechanical advantage systems, you can gain additional mechanical advantage by adding additional pulleys. In this assembly here, we have both our moving pulley down here at the weight and a fixed pulley. So we're applying our force here, where I have the knot. It will go into the pulley and come out the other side, thus giving us a 2-to-1 at this location. Force wraps around and comes back and gives us a third force. So we will be able to easily lift. Obviously, with a 3-to-1 system, you need 3 feet of rope to raise the weight 1 foot. Let's attach our scale and see how much force that was that was applied. And as you can see, the force is significantly less. Our 3-to-1 mechanical advantage system can be quickly and easily converted to a 5-to-1 mechanical advantage by adding more pulleys, or in this case, utilizing both sheaves on our double sheave pulleys here and here. Run it through the additional times. We attach our scale and we lift. And as you can see, once again we've reduced the necessary force to lift the weight. As in the past, since it's a 5-to-1 system, you need to pull on 5 feet of rope for every foot you want to raise the weight. A second type of mechanical advantage system is known as a compound system. In a compound mechanical advantage system, you have one simple mechanical advantage system pulling on a second one, thus increasing your mechanical advantage. Let's take a quick look at the simple system we saw earlier, the 3-to-1 system. As you can see, we're applying our force. It's going through our moving pulley, giving us a 2-to-1 advantage at this point. This single force goes up through the fixed pulley back down, giving us a third force. 3-to-1 mechanical advantage in our simple system. Next, we'll look at a compound system where we have one 3-to-1 system pulling on a second 3-to-1. So here we have our compound system. We have our initial 3-to-1 simple system that we saw earlier. Pulley, with a force applied to it, that force is going back up. So we've got a 2-to-1 coming out. It's going through a double block here. But that first rope is coming back to our friction hitch. So at this point we have a force of 3. Creating a second simple system. Once again, force of 3 going in to our pulley, 3 coming out, so giving us 6 towards our weight. Back up to our fixed pulley with another 3, so 3 plus 6 for 9. Let's test this out with our scale. So we've attached our scale to our compound system, 9-to-1 mechanical advantage, and let's see how we do. To review the two systems we've seen so far, our simple mechanical advantage system and our compound mechanical advantage system, we'll go to the whiteboard here. Here was our 3-to-1 system. A force of 1 is applied, goes around the pulley, so you have 1 coming out. These are additives, so that gives us a force of 2 coming out of the pulley. This force of 1 goes around through the fixed pulley, so it's a redirectional pulley, giving us 1 coming out. So this 2 plus this 1 equals 3-to-1 mechanical advantage. In our compound system, we have our 3-to-1 system pulling on another 3-to-1 system. I've separated our block into 2 single blocks to make it easier to see here on our whiteboard. So we have our first system with a force of 1 going in, going through the pulley, force of 1 coming out, giving us force of 2 coming out of the pulley. This force of 1 goes through the first fixed pulley, giving us 1 coming down. 2 plus the 1 gives us 3 at this point, past our friction hitch. The force of 3 goes to this pulley and comes out the other side as well. Also 3. This 3 plus this 3 gave us 6 coming out of that pulley. This 3, of course, goes up through our second fixed pulley. Comes down at a force of 3. So this 6 plus this 3 equals our 9-to-1 mechanical advantage. Our final type of mechanical advantage system is our complex system. As you know, our compound system was 2 simple systems working together in series, all the forces moving in the same direction. With a complex system, our pulleys are moving in different directions and at different speeds. So let's take a look. We have our force being applied here to our first moving pulley, which has a friction hitch to the rope. The force comes down through the second. This moving pulley here, our second pulley, back up, combining with the friction hitch, and down again. So let's see how they move. And you can see how we have one pulley moving faster than the other. This particular system is a 5-to-1. We've got here our regular 2-to-1 system. And with 1 coming out here, we end up with a 3. 3 coming down. This was 1 coming out, making this a 2-to-1 here. So 3 plus a 2 equal to 5. So why would you use a compound or complex system as opposed to a simple system and just add more pulleys? In a simple system with multiple pulleys, you need a lot of rope. In a 5-to-1 system, as we saw earlier, if you wanted to raise your weight 1 foot, you need to pull on 5 feet of rope. In a compound or complex system, we have friction hitches in our assembly. With the friction hitch, we can raise our weight a given distance, secure it, then adjust our friction hitches, and repeat, thus saving a significant amount of rope in the overall assembly.